Welcome to Inticom Data Science Private Limited. Our mission is to use business intelligence, business analytics, machine learning, engineering concepts to build technology products and solutions for global markets. To understand and undertake applied research and engineering approaches in the domain of business analytics, computational science, artificial intelligence, and data science for product development, which would solve unique real world problems leveraging intellectual property creation. We provide business solutions, thus conceptualized and designed would be published in peer-reviewed platforms like journals, conference proceedings, and henceforth patented. Now let's come to our learning modules on business intelligence. The course background of this module is to have a basic focus on understanding how to leverage and use the data and information assets residing in your organization to create tangible benefits. Significance of the course: professionals with a strong quantitative background in business analytics with a focus on business intelligence and customer analytics are highly desired. This course has been designed to support the participants to develop domain-specific competencies to leverage dynamic aspects of business processes. Let's come to overview to domain: business analytics versus business intelligence versus data mining. Let's understand using set theory. Now explaining the business intelligence and business analytics, we consider tools for consolidating, analyzing, and providing access to vast amounts of data to help user make better business decisions. SAP uses business analytics instead of business intelligence to indicate that business analytics is an umbrella term including data warehousing, business intelligence, enterprise information management, including governance, risk, compliances. But most of the other vendors such as SAS use business analytics to indicate some level of vertical or horizontal domain knowledge tied with statistical or predictive analytics. So principal tools include software for database query and reporting, online analytical processing, business intelligence or analytics that comprises data mining and analytics. Now coming to what is data mining: the computational process of discovering patterns in large data sets using quantitative methods, more discovery driven than OLAP in general. Greater focus is on analytics, finds hidden patterns, relationships in large databases, and infers rules to predict future behavior with a probability of occurrence. Major categories of data mining approaches are pattern associations, clustering, classification, regression, sequence mining, summarization, and anomaly detection. So how does it help in an organization? Business intelligence have components that improves the decision making process, helps you to understand better your business, reduces the risk of bottlenecks, helps identify waste in the system. It's a real-time analysis and quick navigation into data, easy to access and share information. So overview of the domain through this intelligence paradox, we come into play with the business intelligence. It will comprise of analytics, reporting, data warehousing, benchmarking, BPR, that is business process reengineering, OAP, online analytical processing, and data mining. Let's have a quick glance on our business analytics modules. First module is descriptive analytics. Module second is statistical analysis. Module 3 is prescriptive analytics. Module 4 will cover predictive analytics, and the last and most vital module is data science application, that is used to cater industrial requirements. So next we come to descriptive analytics. What is descriptive analytics, or especially if we come to what is in fact descriptive statistics. Descriptive statistics is a summary of statistics that quantitatively describes or summarizes features of a collection of information. It is used to analyze and represent the data that have been previously collected. Next is what is data and variables. Data are pieces of information. Data are made up of objects that have been measured and attributes that were recorded. Objects are subjects, cases, entities, etc. Attributes are characteristics, factors, etc. of those objects. When we measure the attributes of an object, we obtain a value that varies between objects. Consider the people in this class as objects and their height as the attribute. The attribute varies between objects, hence attributes are more collectively known as variables. Now let's come to what are the measurement scales. Amount of information that can be provided by a variable is determined by its type of measurement scale. Variables can be measured on 4 different scales. First one is nominal scale. Data are measured at the nominal level when each case is classified into one of a number of discrete categories. Example: color, political party, gender, jersey number, etc. Next is the ordinal scale. Data are measured on an ordinal scale if the categories imply order. Example: military rank, clothing size, etc. The difference between ranks is consistent in direction but not in magnitude. Next is interval scale. Here, if the differences between values have meanings, the data are measured at the interval scale. Temperature and IQ ratings are examples. Last and most important is the ratio scale. Data measured on a ratio scale have differences that are meaningful and relate to some true 0 points. Example: weight, height and age. This is the most common scale of measurement. Next is measure of position. Position statistics measure the data's central tendency. Central tendency refers to where the data is centered. There are 3 types of central tendency. As you all know, first is mean. It gives average of the scores. Second is median. It calculates the middle score. And third is mode. It gives the most frequent score. So just let's refresh quickly. Mean is the most commonly used statistics of position. It is easy to understand and calculate. It is the average of the sample provided. For example, if we have n values in sample and they have values x1, x2, x3 till xn, then sample mean is the total of all values divided by the size of the data set. It works well when distribution is symmetric and there are no outliers. An outlier is a data point which is significantly greater or smaller than other data point in a data set. Let's understand with a simple example. Consider the following data set of ages of 8 students in the same class. Find the mean of the class. To find mean of the data set, first total all data points is calculated, which is sum is 152. Then it is divided by number of observation to find, and mean is equal to 19. Median is the middle score of data rearranged in ascending order of magnitude. It is less widely used but is a useful statistical parameter due to its robustness. If number of observation in sample is odd, then median is equal to n plus 1 divided by 2, and this is the case when if the observation in a sample is even, then median is the average of n by 2 and n plus 1 by 2 variables. It is often used when data is non-symmetrical, as it can reduce the effect of outliers. Find median of the following data. First, rearrange the data into ascending order. There are odd number of observations, therefore median can calculate by finding the n plus 1 divided by 2th term, that is 6th term is 56. To find the median for even number of observation, it will be n plus 1 divided by second term, and n minus 1 divided by the second term is to be found, that is the 5th and 6th terms. Take the average of the 5th and 6th score to find median, that is 55.5 for this data set. Next is the mode, and is the most frequent score. It is rarely used as a central tendency measure. It is mostly used in categorical data, that is nominal type of variables. Consider same examples of age of 8 students in a class. To find mode, find the most frequent age. The mode of age is 19, which occurs 4 times. So central tendency, from information provided earlier, try and answer which central tendency should be used in each of the following sample data sets. Here is a 10 patients are waiting at a doctor's clinic for the following duration of time given in minutes. In this case, the medians would be the preferred measures of central tendency to use and not the mean, since there is an outlier of 55 minutes. Therefore, the outlier is a freak value and should be disregarded. The mode would not be suitable because it is just chance that two patients, patient number 1 and 10, waited for the same period of time and all the others waited for different period of time. Next is, what is the appropriate measure of central tendency to use with the data? Here method of transport is given and number of the students who have used those method of transport. Here mode is appropriate measure of central tendency to use, since categorical data is being dealt here with. Example 3. Following values are number of customers a restaurant is served for lunch on 10 consecutive days. Here the mean will be the best central tendency to use in this case, because the ratio data is being used here. There are also no outliers present in this data. Therefore, mean would be more appropriate than median. Summary of when to use mean, median and mode. Following is the summary of when we are using the central tendency according to the dataset provided. If the type of variable is nominal or categorical, then mode is preferred. If it is of ordinal or interval or ratio but skewed, then median is used for best representation of central tendency. Mean is used when we have interval or ratio type of variable which does not contain any outlier and is not skewed, as we have seen in the previous 3 examples. Next is the measure of spread. The spread refers to how the data deviates from the position measures. It gives an indication of the amount of variation in the process. there are different statistics by which we can describe the spread of a data set. First one is the range. It is defined as difference between highest and lowest value in the data set. Second one is variance. It is a measure of the variation around the mean. Third one is standard deviation. It is the average distance of the data points from their own mean. So what is range? Range is calculated by finding the difference between the highest and lowest value of sample data. It is the simplest measure of variability and is denoted by R. It does not make full use of the available data, and it can be misleading when data is skewed or in the presence of outlier. Just one outlier will increase the range dramatically. Now next question is, what is variance? Variance measures how far a set of data points are spread out from their mean. Variance is calculated by first finding the deviation of each element in the dataset from the mean and then by squaring it. Variance is the average of all squared deviations. The units of variance are the square of the units used for the original data. For example, a variable measured in meters will have a variance measured in meters squared. So let's take with an example and understand what is variance. Consider the following data of age and find its variance. First step is to calculate the mean of data by totaling the data and dividing by number of observation, as we have done previously. Hence the mean is found to be 27.57. Then find deviations of each data point from the mean by subtracting the mean from it and then squaring the deviation to obtain deviation squared of each data point. The variance is the average deviation squared and is found to be 7.6329. Next comes, what is then standard deviation? It is the average distance of the data points from their own mean. A low standard deviation indicates that the data points are clustered around the mean. A large standard deviation indicates that they are widely scattered around the mean. Value 0 for standard deviation indicates that either all data points in dataset have same or 0 values. To find standard deviation of a dataset, calculate the square root of the variance. Consider the same example of age. Then standard deviation will be square root of variance, that is square root of 7.6329. It comes as 2.7627. Try and tell which figure should have a higher standard deviation just by looking at the figures of distribution. So the answer will be the figure A has a higher standard deviation because it is more spread out than figure B. Now let's come to measure of shape. Data can be plotted into a histogram to have a general idea of its shape or distribution. The shape can reveal a lot of information about the data. Data will always follow some kind of known distribution. It may be symmetrical or non-symmetrical. In a symmetrical distribution, the two sides of distribution are a mirror image of each other. The shape helps in identifying which descriptive statistics is more appropriate to use in a given situation. If the data is symmetrical, then we may use the mean or median to measure the central tendency, and if the data is skewed, then the median will be more appropriate measure of central tendency, as discussed earlier. Two common statistics that measure shape of data are skewness and kurtosis. So let's refresh again. What is skewness? Describe whether the data is distributed asymmetrically around the mean is called the skewness. A skewness value of 0 indicates perfect symmetry, whereas A negative value implies left skewed data and a positive value implies right skewed data. Now what is kurtosis? Let's refresh. It is the measure of degree of flatness or peakness of the shape. When the data values are clustered around the middle, then the distribution is more peaked and thus has a greater kurtosis value. When the data values are spread around more evenly, then the distribution is more flattened, thus having a smaller kurtosis value. There are three types of kurtosis based on their values, namely leptokurtic, a tall and thin distribution you can see in the graph. Next is the mesokurtic, it's looking almost a normal distribution. And last but not the least is a platykurtic, which is a flat and wide distribution. So let's see how we work on descriptive statistics using Excel. All the measures of descriptive statistics can easily be calculated using Microsoft Excel. Microsoft Excel is a spreadsheet developed by Microsoft for Windows, Mac OS, Android and iOS, featuring calculations and graphical tools, etc. So let's come to Excel, where we'll show how to add analysis tool pack add-in, which will be used in order to work on our problems. So follow the steps for installing analysis tool pack. To install analysis tool pack add-in, first open Excel and click on File button on the top left corner. Then click on Options and click on Add-ins. Here select Excel add-ins in the Manage drop down and click Go. Check on Analysis tool pack and click on OK. Install the Analysis tool pack. After installing data analysis, button will be visible under the data tab. Next is how to use descriptive statistics using Excel. Let us consider an example in Excel and see how to solve it using analysis tool pack. The following is the data about age of 15 students in a class. To find descriptive statistics, use analysis tool pack. Then go to data and click on data analysis. Under data analysis, click on descriptive statistics and click OK. Select the input range as the age column. Check levels in first row, since the first cell contains the level. Then click on output range and select where to display the output. Check summary statistics to get all the basic statistical values about the data. Then click on OK. All the descriptive statistics function are now visible about the age of the students. It can be seen from the data that the distribution has a high kurtosis value, meaning that the data is more concentrated, and it is positively skewed, meaning most of the data is less than the mean of the data. Now let's go back to slide to learn about the next sub feature, that is correlation. So correlation is a statistical measure which shows relationship between two or more variables moving in the same or in opposite direction. For example, height and weight are related. Taller people tend to be more heavier than shorter people. So how to measure it? So let's consider Karl Pearson correlation coefficient. The main result of a correlation is called the correlation coefficient. It ranges from -1 to +1. The closer R is to +1 or -1, the more closely the two variables are related. If R is close to 0, it means there is no relationship between the variables. If R is positive, it means that as one variable gets larger, the other gets larger, and if R is negative, it means that as one gets larger, the other variable gets smaller. The Karl-Pearson coefficient can be found using the formula as given, where R is within bracket 1 by n minus 1 multiplied by summation x in x multiplied y minus n x prime y prime divided by sx and sy, where n is number of observation, x and y are two variables, and x prime y prime are their means, sx sy are their respective standard deviations. Coefficient of determination. Coefficient of determination is the primary way we may measure the extent or strength of associations that exist between two variables x and y. It is denoted by r square and is the square of Karl-Pearson's correlation coefficient. Now let's consider a problem to understand it better. The problem we discuss is a teacher wants to find out the relation between the number of hours studied and the marks scored by the students in an examination. She randomly selects 10 students to track how many hours they have studied and their marks obtained. Now find out how the number of hours studied has affected on examination scores. The following is the data obtained. Here we have data of 10 students, where x is number of hours studied by the students and y is their respective marks scored in exams. To find the solution, first find the total of each variable and also the total of their product. The following information will be used to find the correlation coefficient. Find the mean of x and y by dividing their totals by 10 to get 4.7 and 79.9 respectively. Calculate the standard deviation of x and y to get 2.1628 and 11.5706 respectively. Now the formula for correlation coefficient of Karl-Pearson correlation R is equal to within bracket 1 divided by n minus 1 multiplied by within bracket summation xy minus n multiplied by x prime y prime entirely divided by sx multiplied by sy. Here it can be observed that summation of xy is 3939, x prime y prime are the means of x and y, calculated to be 4.7 and 79.9 respectively. Standard deviation is denoted by sx and sy, which are calculated to be 2.1628 and 11.5706. When we apply the values, we get the coefficient of correlation equal to 0.8156. To find the strength of association between the two variables, calculate the coefficient of determination by squaring the coefficient to get 0.66, which implies 66%. This will be more explained in the predictive analysis when we discuss the relationship between correlation and regression. Therefore, it can be concluded that the score in examination is directly related to the number of hours studied to a significant extent. Further, it can be said that there is a positive correlation between the number of hours studied and the score obtained in the examination. Now, you will find it much more easier when we use correlation using Excel. The Karl-Pearson correlation coefficient can easily be calculated using Excel when we employ the inbuilt correl function. The correl function takes two arrays, that is the variables, as its arguments and give back the value of coefficient. Consider the same problem in Excel and try to find the solution using correl function. To find the correlation using Excel, make use of the correl function in Excel. Select the cell where the output of correlation coefficient is required and type is equal to correl. Then select number of hours studied, row as first array, and then select exam score as second array. Press enter. The correlation coefficient is calculated. It can be seen it is same as calculated before. To find coefficient of determination, square the correlation coefficient by using the Excel's power function. Select the cell where the coefficient of determination is required, type is equal to power and select correlation coefficient, and as second argument type 2 to square it. Press enter to obtain the final result. It can be seen that the results found here are same as calculated earlier, but it is much easier and faster to reproduce using Excel's functionality. So we can conclude our session on descriptive statistics. Hope you have enjoyed it, and the lessons on probability distribution, which will be very interesting, will be subsequently taken in the upcoming videos. However, if you have any queries, please feel free to contact us for clarification, and you can email at the following addresses. Thank you.